In this video, we're going to be going over more ionic compound naming and formula writing. The trick here is that the metals in this case can have different charges. So because they have different charges, they'll wind up having different chemical formulas, and we have to be able to identify between them. You're going to want your periodic table / chart of charges for this, your notebook, your writing implement. We will be doing a tiny little bit of algebra. So be ready to do that, but it's nothing really hard. Right, so the reason why we want to work with multiple oxidation compounds is that, again, some elements can form multiple charges. Iron will typically form a +2 charge or a +3 charge. Gold will be +1 or +3. Now we have to be able to separate between these charges because, again, the different compounds formed from these different charges are not going to be the same, so we have to identify them uniquely. The way we do that is we use a Roman numeral. Right, so when we're talking about iron with a +2 charge, we call that iron 2. So it's iron with a Roman numeral 2. Iron with a +3 charge is iron with a Roman numeral 3. Now, when you actually are trying to name from a formula, what we do is we work backwards, and we use a little bit of algebra to find it. The way that this works is, remember, the total charge of the compound has to equalize out, right? So the total charges of all of the metals in our compound have to equal the total negative charges of our anions. So here's how we're going to use algebra to do this. I'm going to work with the one over on the right first, and then I'm going to have you guys try the one over on the left. So for the one over on the right, we have W, which is the element tungsten. We have oxygen, but because it's the negatively charged ion in this case, it's oxide. So we have a tungsten oxide. The problem is, tungsten can have a charge anywhere from +1 all the way up through +7. So we have to figure out which one is which. What we're going to do here is we know that the positive charge plus the negative charge has to equal 0 because the atom has to be neutral. We don't know the positive charge, so I'm going to call that X. Now, because there are two tungstens, we don't just have one X, we have 2X. Right, so 2X plus something equals 0. How do we get that something? Well, oxide has a -2 charge. There are 5 oxides, right? So we have 5 copies of that -2. 5 copies of a -2 will add up to -10. So we have 2X for our tungsten, -10 for the charges of all of the oxygens, all 5 of them, equals 0. What's X? Right, in this case, X is going to be +5. So the name of our compound is tungsten, Roman numeral 5, oxide. Right? That's all we have to do to it, is we just work with our unknown as X. The subscript next to it tells you how many X's you have. Then you write out the total negative charge, set them equal to 0, solve for X. So for the one on the left, I want you to try sulfur in this, sorry, not sulfur, lead in this lead sulfite compound. Right? What is the charge of this lead ion? Take a couple of minutes, and once you think you have it, pick it back up. Okay, so this lead's a little bit easier to figure out than the tungsten is, right? We don't know the charge of lead, so we're going to call it X. There's only one lead atom, so we're going to say just X. Sulfite has a -2 charge, and there are 2 of them. So -2 times 2 means -4. So X minus 4 equals 0. X in this case is +4. So the name of this compound is lead 4 sulfite. Right? That's all there is to working with multiple oxidation elements. If you can do regular ionic naming and formula writing, this isn't that much extra. Okay, in the next video, what we're actually going to cover is we'll cover molecular compounds, aka compounds that are covalently bonded. Naming those is really simple as long as you know your geometry.